Hello everyone and welcome to today's Section J Code Change webinar. My name is Tom Symons. I'm an ESD consultant here at SUHO and I'm currently the Section J team coordinator. Hoping today to sort of explain a few things around the code change for 2019 and hopefully sort of assist you with understanding, I guess, a few of the key points. And also making the process smoother for when you require a Section J assessment in the future. Obviously, it was a bit of a messy code change. There was a grace period for a year as we transitioned from 2016 code to 2019 code. And now, in most states at least, everyone's moved over to the Volume 1 2019 code from the 1st of May. Obviously, WA has also got a grace period, so that means that those of you who are working on WA projects still have a further year where you can use the 2016 code if you see fit. But at the end of the day, it's all up to the certifier or project's building surveyor. If you've got projects that are relatively already well documented, it's certainly worthwhile checking in with them as to which code they expect it to be certified to, because we're still certainly seeing projects go through under 2016. And that's going to be, at the end of the day, a simpler assessment process and probably also going to have some cost savings in it as well, if that's what you're after. Firstly, we'll just touch on the two sort of key pathways for Section J. Obviously, like most parts of the code, there's the deemed to satisfy pathway, which is where you've got each of your building elements have to comply. So that's your roof, walls, glazing and floor. Traditionally, that's a cheaper assessment cost, but pretty much always a higher build cost. And that's why for 2016, the JV3 pathway was so popular. It's because it allows a more holistic approach. We model the building as opposed to just assessing it and doing some calculations in deemed to satisfy. And so for the JV3, we're modeling it. We have a proposed and reference building, and as long as the proposed building produces less greenhouse gas emissions than the reference building, then your building complies. And so that allows us a bit more flexibility around the design, so you can adjust insulation and glazing specifications. You might decide that you want a bit more insulation on your roof to sort of balance out a little less underneath your floors, or have a slightly decreased glazing specification. It just allows that flexibility. And at the end of the day, this is a higher assessment cost, but pretty much always results in a cheaper build cost, and that's why it was so popular for 2016, and we probably expect it will still remain to be the more popular option. In terms of the key areas of change, obviously the building envelope has had a number of improvements. That's around the fact that thermal bridging is now included for 2019. You've also got the Façade Calculator, which is added as well. There's obviously also improvements in efficiencies around lighting and control, and also HVAC systems. And then the other sort of biggest, I guess, addition is thermal comfort, which is now required for all JV3 assessments. At the end of the day, the code's tried to sort of, I suppose, narrow the gap between deemed to satisfy assessments and JV3 assessments. And one way that they're trying to do that, and to try and make sure that buildings are more built with energy efficiency and people's comfort more in mind, is by adding the thermal comfort assessment to all JV3 assessments. So firstly, we'll touch on thermal bridging and then move into deemed to satisfy side of things, and then we'll go over to the JV3 side. So thermal bridging is a big addition to the code. It's currently only for the Section J code, which is the commercial side of it, but effectively we're talking about where you've got insulation within a framed wall, roof or floor. So anywhere where insulation, like bulk insulation, is sitting between framed members, those framing members are greatly reducing the effectiveness of that insulation layer. You can see on this example on the right hand side, you can see all the studs of the wall are leaking a lot more heat through those framed sections, as opposed to the areas where you've got insulation in between them. I've got a quick example here to kind of demonstrate the impact that thermal bridging has on the achieved R value. So we're using Australian standards to calculate this as per the requirements in the code. If you were to consider a framed wall that's say 2.7 high, it could be timber or metal stud, but we're assuming the dimensions of that timber or metal C channel are the same, so 90 by 35. We've got a stud spacing of 450 and noggin spacing of 1350, so a relatively standard wall. For 2016, whether or not it was timber or metal stud, it didn't matter. It achieved 2.5 because we weren't factoring in that sort of 12-15% of bridging. For 2019, you can see that it actually greatly impacts the actual R value of that layer. So in this case, we're just considering that layer of frame and insulation. If it's a timber stud wall, it's achieving about R1.8. And if we've got a metal stud wall, it's actually only achieving R0.8. So you can see how much of an impact actually factoring in thermal bridging has. The other key thing to point out is by adding continuous insulation, or in this case the thermal break tape, just to the frame members, we can increase the R value, the effective R value of that R2.5 in a metal frame to about R1.4, which isn't amazing, but at least it's something. I suppose the key things to touch on for thermal bridging are that steel frames are still okay. It's just understanding how we've got to treat them, and that thermal bridging obviously does have a slightly greater impact on on metal frames than timber frames. And at the end of the day, the continuous insulation is key. So adding more bulk insulation between that frame doesn't help. So we could increase, in the example that we have here, if we increase this insulation between the frame, say to R4, and it's a metal stud, it might only achieve in the low R1s. Throwing more bulk insulation doesn't help because of how poorly that sort of 10 to 15% of frame performs. And so that's where continuous insulation is really pretty critical to improving the R value performance, particularly on metal frames. So we'll touch on a couple of the DTS requirements. You can see that for those of you who are familiar with 2016 code, the R values here aren't too different from 2016. The minimum R value requirements have been simplified, so there's no longer the scale where if you've got different roof colors, you have different R value requirements. It's as simple as just R3.7 for climate zones 1 to 5, which is obviously most capital cities. And then you've got R3.2 for climate zone 6, which is Melbourne. Obviously, we're now factoring in bridging. And so anywhere where we've got insulation between, say, a ceiling joist, but also a stud wall or a floor joist, is greatly impacting the effectiveness of that insulation. So it's not as simple as just having a bulk insulation of R4 and it achieving that requirement. One of the other changes for DTS is that lighter roof colors are now a requirement. So the solar absorptions has to be less than 0.45, and that limits you to the 5 ColourBond colors on the right hand side of the screen. Importantly, it also excludes zinc alume, which certainly has impacted some of our clients, at least on the, I suppose, more cost concerned point of the market. For the floors, R2 is still the requirement if you've got no in-slab heating or cooling for most climate zones, and that's both concrete slab on ground and suspended floors. The interesting thing here is that that's now being included for concrete slab on ground for climate zones 1 to 6, which previously wasn't the case. And there's an interesting tipping point there. So anywhere where you've got if you've got a building that's around 300 to 400 square meters, there's actually a calculation where we can include the soil resistance R value. And often the soil resistance R value, if you've got a building that's above sort of 300 to 400 square meters, will actually be great enough that you don't actually require any insulation underneath the slab. Another interesting point around floor insulation is that often in daytime operating buildings, if we go to the JV3 model, once we add insulation to the reference building under the slab, it actually often performs worse. So if that's, I guess, one of those key tipping points between JV3 and DTS, if you're looking for a darker roof color, you're likely to have to go, well, you will have to go JV3. And it's also the same for if you're looking to avoid having concrete slab on ground insulation, if your slab's less than about 300 square meters. So now we'll touch on the wall and glazing calculator. Effectively for 2019, the walls and glazing have been combined as one system. There's two calculation methods for this for each floor level. So either it's method 1, which is per orientation. For 2019, that's been simplified to north, east, south, and west. The 2016 glazing calculator was actually in 8 orientations. And then you've got method 2, which is the combined result. Method 2 we expect is probably going to be the preferred option because that's going to give you a balanced result or in terms of the requirements for your glazing for the whole for the whole floor level. And it's one of the key things here to mention is the wall to glazing ratio, which we'll touch on in a few slides' time. Importantly, to achieve the DTS requirements, we have to achieve a minimum wall R value initially, and then we've developed our own calculator in-house to do the facade calculations, and that allows us to then tell you what the requirements are for your maximum glazing U value and your maximum solar heat gain requirement. So this is, I suppose, the key tipping point for the glazing in terms of percentage. So the code's effectively considered that if you've got more than 20% glass, your glazing is the real driver in the situation. So therefore, it's actually only requiring you to have a wall R value of R1, which is generally relatively easy to achieve, even if you're not really trying to avoid thermal bridging. If you've got less than 20% glass though, the code's considering that the wall is now the dominant player and the glass percentage is low enough that it's not having a huge impact, and therefore that wall R values become more prominent. So for daytime operating buildings, you're looking at about R1.4 for most climate zones. That's for climate zones 2 to 7. And then for the nighttime operating buildings, which is class 3, 9A ward and 9C, you've got higher wall R value requirements, which can be anywhere from sort of 1.4 in climate zone 2 to 5, but can also be up to R3.3 in climate zone 1 and 4, I believe. But so it can sort of range. There's a couple of others in between there, but R3.3 is actually quite hard to achieve when for at least, especially for the modular builders that we work with. But even for in situ builders, R3.3 is certainly going to be looking at having some continuous insulation in there. Throwing insulation in between stud frames isn't going to get you close to R3.3 at the end of the day. These two plots sort of quickly show or demonstrate the increase in stringency for glazing. So as you'd expect, the code's tried to sort of tighten both the U value requirement for glazing and the solar heat gain. You can see the blue lines in both are 2016 and the orange lines show the increase for 2019, generally from about 25%. So before, if your glazing to facade ratio is less than 25%, generally we're not seeing too much of a change in terms of the glazing performance requirements. If it's greater than 25% though, you can certainly see that there's an increase, especially for the glazing U value. Okay, so we'll just touch on a couple of examples here, sort of just to demonstrate deemed to satisfy requirements, I suppose. This is a single-story classroom building. It's class 9B, so it's daytime operating, and it's in climate zone 5. It's concrete slab on ground. It's got approximately 35% glass to the north, east, and south. North is up the page on the floor plan there. And all the glazing, importantly, is well shaded. So there's probably between 2 to 4 meters of shading over all of the glazing in the building. So as we mentioned earlier, for 2016, there was a bit of a stepping requirement for the roof R value requirement between R3.2 and R4.2, and that was based on the color of the roof. For 2019, they've simplified it. It's just straight R3.7. We've got to factor in bridging, as we mentioned earlier, and the lighter color requirement is now applied, so that's limiting you to those 5 ColourBond colors on the roof page that we showed earlier. For the walls, R2.8 is probably relatively similar to about the R1.4 bridged, which was the requirement for the method 1 here. And you can see that the big change here is that the glazing U value has increased or decreased to much closer to a high performance single glazed option versus the 2016 requirement, which pretty much let you have anything. Any single glazed clear 3 to 5 mil would have sort of achieved those sort of numbers, and now it's sitting at a high performance single glazed. And as we mentioned earlier, the other thing that's sort of key to know is that method 1 provided individual results for north, east and south in this case, as west didn't have any glazing on it, and then the method 2 gave you a sort of more balanced result in between those method 1 results. Important to mention here that the solar heat gain for the glazing hasn't changed between 2016 and 2019, and that's because of the amount of shading on this building. So we'll see on the next example that it's certainly increased in stringency. It's just in this case it's not actually showing. As we mentioned earlier, concrete slab on ground do require slab insulation in climate zones 1 to 6 now. The total R value requirement being R2, but in this case there was actually new insulation required because of the slab size, and that's because of the soil resistance calculation, which is in table J1.6. We'll quickly touch on this class 3 welcome house, more I suppose to demonstrate the change in glass requirements as opposed to anything else. This building has slightly less glazing in terms of percentage, between 17 and 30%, but the important thing is the eaves shade the glass a lot less than what was in the previous example, probably by about 900 mil. You can see for the 2016 glazing calculator it was sort of around that high performance single glazed, and for this one it's certainly come into probably more like closer to double glazed mark, certainly for method 2 at around a U value of 3, and the glazing solar heat gain in this case, as demonstrated, has certainly increased in stringency. Yes, and then so for the only other thing worth mentioning is that for the floors, in this case, because it's got a relatively unique perimeter, the ratio of perimeter to floor area is how we calculate what the soil resistance value is. And in this case, because it's got quite a high perimeter, even though it's probably closer to 400 square meters in floor area, it's actually still requiring some level of slab insulation at around 0.4. Hi Getty, just reading your question. Yeah, that's correct. So other codes around the world certainly consider the impact of fasteners, point bridging and that sort of thing. At this stage, the code's running off the New Zealand standard 4214, which is only factoring in, I suppose, bridging of actual framing members. At the end of the day, it's probably not ideal, but it's an introduction to thermal bridging, which at least is getting the ball rolling in Australia. For 2019 code for residential, they're still not even factoring it in. So hopefully at the next code we'll start to, I guess, ramp it up a bit more. It'll be brought in for residential, and hopefully we'll start to get to that point where we're actually considering point bridging and fasteners and that sort of thing as well. A couple of last points for the facade calculation. The way we've set up our calculator at SUHO is the glazing U value and the wall R value are actually in balance. So that means that increasing the wall R value may give you slightly more leniency for your glazing U value if, say, you might be right on the edge of between double glazing and single glazing, or high performance single glazing at least. And the other key thing to know is that the window solar heat gain is in balance with the external area of the glazing, or I suppose the percentage of external glazing, and also the shading. So if you're looking for a bit more allowance for your solar heat gain, maybe you're looking at maybe a slightly more clear glazing option, then it's going to be all about shading or reducing the amount of glass you've got. So that's the end of the DTS side of it. If you've got any further questions, please mention them in the comments and I'm happy to answer any. For the thermal comfort side, it's for the thermal comfort side, it's the JV3 pathway now requires it for all assessments. This is, I suppose, really to stop. Under 2016, it was quite easy to get buildings to pass through JV3, and so thermal comfort has been introduced to at least add a layer of requirement where, at least hopefully, we're starting to factor in the thermal comfort of the occupants. Often for 2016, buildings would be able to get buildings to pass by sort of swinging them one way or the other, and that meant that it might perform well, say in summer or winter, but it would probably perform quite poorly in the other season. And so I suppose the thermal comfort is starting at least at an introduction level to try and pull that back. Importantly, it's really an introduction for the 2019 code. So the PMV, which is the predicted mean vote, which is our measurement of the occupant's thermal comfort, has to be between -1 and +1 for 98% of operational time. So slightly cool to slightly warm, which you can see on this graph here, is equivalent to about 75% of the occupants being comfortable, or if you're looking at the side of the table there, 25% being dissatisfied with the conditions between slightly warm and slightly cool. So this is really, as I mentioned, an introduction. For Green Star, you get additional points if you're targeting between -0.5 and +0.5 PMV. So far from the JV3 assessments that we've done, we haven't found it too hard to get buildings to achieve the thermal comfort side of it between -1 and +1, but a lot of them aren't achieving between, say, -0.5 and +0.5, which is much more of a higher end Green Star sort of target. And even then, some Green Star projects probably wouldn't hit that target anyway. To give you a general idea of how the PMV is calculated, we're using our model that we use for the JV3 assessment with our proposed services and our proposed fabrics. And then the model's factoring in, to calculate the PMV, it's factoring in the factors on the right-hand side, which are air temperature, air velocity, the radiant temperature from the sun, and the relative humidity. And then it's also factoring in what the occupants are doing based on their activity level, and the clothing that they're wearing. So that's the amount of insulation that they've got on. Those 6 factors are factored into one calculation, which then spits out a PMV on an hourly basis in our model, and we're targeting for 98% of operational time for that PMV to be between the -1 and +1 target. Touched on a few of those things. So the code requires spaces to be assessed for thermal comfort where people spend a reasonable amount of time. So anywhere where they're actually sitting down, like classrooms, offices, lunchrooms, but we're excluding things like transitory spaces, and also toilets and storerooms as examples. So effectively, anywhere where you'd expect them to actually spend a reasonable amount of time, we're factoring those spaces in, and anywhere where they're sort of just passing through, they're allowed to be excluded from the assessment. Early indications so far is that it's certainly critical, at least for this type of assessment, that HVAC is included for all rooms that have to be assessed for thermal comfort. I suppose ideally from a sustainability point of view, buildings would be more sort of passively designed, but at this stage, most projects aren't really designed that way, and so generally the thermal comfort is heavily reliant on an effective HVAC system. Therefore, knowing all the HVAC details are key to actually being able to pass a thermal comfort assessment, particularly around sort of, ideally, we can sort of check out your mechanical spec and mechanical layout. Sometimes you won't have that at an earlier stage if we're doing an assessment earlier on in the design process. But if that's the case, then we just need to make assumptions with you to sort of work out what the likely air conditioning system will be. One of the other things that probably was a little bit surprising to us, but seems to be working so far, is that thermal comfort is proving to be possible, even in climate zone 1 for some of the lightweight buildings that we assess. So some of the clients, particularly modular builders, are relatively excited about that because the high wall R-value requirements are something that they're not particularly fond of. And that's specifically really for climate zone 1 because you've got to achieve R2.4 for daytime buildings and R3.3 for nighttime operating buildings for the walls. In terms of the JV3, other changes to the JV3 pathway. There was a heap of work going on in the back end of our modelling, assessment, profiles, etc. The other key thing to note is that now Green Star and Neighbours both have pathways within Section J. So previously, if you were doing Neighbours or Green Star projects, you still generally had to do a JV3 assessment, even though you were doing a heap of modelling, which was generally more complete for the Neighbours and Green Star. Now they've actually provided pathways for JV1 for Neighbours, JV2 for Green Star, which will allow you to align the modelling that you do for those other assessment tools to achieve Section J compliance as well. So it should just be a smoother assessment pathway at the end of the day. In terms of HVAC, it's the Section J5 part of the code has probably doubled in size. It's become a lot more complicated. Previously for 2016, it was generally a bit more of a tick box sort of situation where we were just checking for certain that certain things were included in the design. Now there's a couple more calculators for pumps and fan systems, and at the end of the day, that's just about trying to improve the efficiency of the HVAC system and make sure that it's meeting the minimum requirements of the code. For the lighting, ironically, 2016 code was actually based on T8 fluorescent lights, which probably should have been updated years ago. Obviously, most people have been using LEDs for years now, and so 2019 is really just bringing the lighting requirements up to LED standards. That means that the allowances for rooms are probably halved in most cases. For example, an office dropping from 9 watts per square meter to 4.5 watts per square meter. But generally, it's actually, so far, we haven't had too much of an issue with it. As long as you're using LEDs, as long as you've got appropriate control devices, it shouldn't really be any issue. Probably a couple of points here to touch on. Offsets can have had a little bit more input provided by the supporting documents of the code. That's the ability to offset your building's energy consumption or greenhouse gas emissions at the end of the day for the proposed building with on-site solar or renewable energy. Effectively, our interpretation is that renewable energy should be both generated and used on-site. That means really it has to be stored on-site because it has to be used, it has to be both generated and then used for Section J related services, whether or not that's the lighting, that's the HVAC system, etc. The other interesting one that's a bit of a interesting clause added to the code is the JV4 post-construction blower door test option, which is assessing the building's air infiltration. Effectively, there's now two ways to prove that you meet the building sealing requirements. There's J3, which was the traditional route, which is more of a deemed to satisfy option, saying that you'll have appropriate door seals, window seals, you'll have exhaust fan dampeners, stopping drafts from coming through at the end of the day. That's what it's all about. The other option now is to have a post-construction blower door test through the JV4 clause. Wouldn't have expected too many people would opt for that option, given that you're probably going to have all of those building sealing sort of devices on your building anyway to be able to achieve the air tightness requirement. But it's certainly an interesting introduction, and I suppose similar to both thermal comfort and maybe even a little bit thermal bridging. Thermal bridging's certainly impacting the code and adding an additional challenge to achieving the requirements. But as Gertie mentioned, at this stage it's probably still a bit more of an introduction as opposed to the full-blown consideration of the impacts of thermal bridging. JV4 is doing exactly the same thing. It's really an introduction, which is sort of an additional side clause, but we'd certainly expect it to be beefed up for future codes. This is, I suppose, our suggested compliance pathway, particularly for larger projects. And we're really suggesting a preliminary DTS check at concept stage. That's going to do a couple of things. It's going to hopefully prevent any surprises further down the track, particularly as 2019 code is new and people, maybe some clients haven't had a 2019 project yet. It's at least going to allow you to identify what your worst or what your maximum glazing requirements are. And if you're content with those results, then we can continue on the DTS assessment pathway. It's actually the cheaper compliance pathway anyway. Alternatively, if your client has to have a darker roof color, if you don't want under slab insulation, if your slab's on the smaller side in terms of area, or maybe you're just looking for a slightly more flexible solution, then JV3 is still probably the obvious option if any of those things arise. And then we continue on through for the final JV3 report. Some other handy sort of tips or considerations, I suppose. One of the big risks of having thermal bridging included in this code is that insulation layers for walls in particular are going to have to be beefed up. Potentially also, if you've got a suspended floor that's lightweight, there's going to have to be some level of continuous insulation, and these additional layers of insulation are potentially going to sort of mean that the fabrics are more complicated, but also there's potentially a higher risk of condensation issues coming up. Important thing to note is that Section J assessments are only really considering energy requirements, and so although a particular design might achieve what the R value that you're looking for the Section J side of it, they're not considering things like condensation, and so it's certainly worthwhile considering that. Our studio team can also provide advice around that if you're interested. In terms of alterations to existing buildings as well, often DTS is, I suppose, crudely put, a simpler option, as only altered or new fabrics have to comply to the Section J requirements for the new code. If we go a JV3 assessment, it poses a couple of additional risks potentially to your design. One, thermal comfort makes the process more difficult, and particularly for buildings where if you're only replacing, say, 30 to 50% of the fabrics and the other half of the building isn't being touched, there's the risk that the poor performing existing fabrics, if the building's say 20 or 30 years old, might not perform well enough to actually achieve a thermal comfort result. I suppose the other thing is that if you're only replacing, say, a roof or something like that, potentially there's not really enough for us to model to allow for a flexible solution for that roof requirement. And so potentially you're better off just going a DTS solution anyway, because it's going to be quicker and more cost effective from a compliance point of view. A couple of things in terms of what we need as consultants. To quote, we're always going to ask for floor plans, elevations, the building class, and which areas are conditioned. That's particularly the case for if we're quoting for JV3 and have to consider a thermal comfort assessment as part of that. To assess the building, most of those things are probably relatively common for people who've worked with us in the past. Obviously, we need to know about your building fabrics, the colors, the preferred insulation levels. A key one for 2019 is those framing details. That's for your roofs, walls, floors, anywhere where there's a frame. Really, we're going to have to consider it. And anyone who can do an assessment without knowing those details isn't doing it properly. The other key thing to note is previously for 2016 there was probably a little bit less requirement to understand your air conditioning details and as much detail as what we have to for 2019, and that's because of the addition of thermal comfort. We're going to have to either, if you can provide a mechanical spec and layout, that's great. Alternatively, we can sort of make some assumptions with you. Generally, we're looking for things like your heating and cooling capacity of the unit, what type of unit it is, and also your COPs and EERs. At the end of the day, I suppose worthwhile mentioning this is our last slide, so if anyone's got any questions, please feel free to add them in the chat, and I'm happy to have a conversation. take-home message really is, obviously this is an increase in stringency. The code's trying to push eventually towards being net zero. And so the target for this code was approximately a 30% reduction. That's made up by sort of 7 to 10% fabrics, and the remainder being on services, as opposed to 2016 code. We're highly recommending that check at concept stage. It's really sort of, I guess, just making sure that you're aware of what the requirements will be, particularly around glazing, but also because of the addition of thermal bridging. It's certainly caught a few people off guard. We can also do those at sort of tender stage if you're interested. They're relatively quick and cheap, sort of between 3 to 4 hours work depending on the size of the project. And that just will give you a bit of a heads up as to what the potential requirements might be if you're pricing something. For 2016, our JV3 versus DTS assessments was about 95 versus 5%, heavily towards JV3 because I suppose it just allowed that additional flexibility. So far, we're probably seeing about 50-50 for 2019 for the first 2.5 months of the code change. It'll be interesting to see where that settles. And I suppose the last thing which we touched on first, if you've got any projects that have been underway for a number of years, maybe even 6 months, certainly worthwhile checking with your building surveyor or certifier as to which code you're looking, or they are looking to get assessed to. And that wraps up today's Section J workshop webinar. If you've got any questions, please feel free to send them through to our commercial@suho.com.au inbox, or you can give us a call on 1300 308 525. I'm more than happy to provide advice around Section J requirements. If you've got any questions around, effectively anything to do with 2019. Thanks for attending today, and if you have any questions, please feel free to reach out.